welcome you all to my YouTube channel Java Fun. Today we're going to talk about factorial. What exactly is the factorial? How to calculate the factorial of a number? What are the different methods available in Java to calculate the factorial of a number? And how to program those things using a Java programming program. There are two main methods by which you can calculate the factorial of a number. First is by using loop, the traditional Java for loop or any of the loop, and the second is by using recursion. So in this lecture we will find it out how to calculate factorial using recursion. If you want to find it out how to do it in loop, I have created a separate programming video around it, and I'll put the video link into the description box, or you can find it out in the playlist itself. Again, if you are coming to my channel for the first time, please do like, share and subscribe, and don't forget to press the notification bell as well, because we used to create programming videos which will be very beneficial if anyone is trying to prepare for a Java programming knowledge, Java programming interview, or even if you are not, you want to learn the Java language itself. It will give you a deep insights within what is an algorithm is, how to calculate the complexities, how to solve different programming problems. So I have created the whole series of Java programming questions. Please go through it. So without spending much time onto this one, let's find it out. What exactly is the factorial? So factorial is nothing but, according to the Wikipedia definition, it is nothing but a multiplication or the product of all the positive integers which are less than or equal to the number itself. So let's get an example and let's illustrate it further. So if I want to calculate the factorial of n, it will be nothing but the multiplication of n and all the positive integers which are less than n. So n factorial is n into n minus 1 into n minus 2, so on so forth till 1. So it will be multiplication of all those values, which will be a factorial of n. So if you take the real world example, I want to calculate the factorial of, let's say, 5. So factorial of 5 is nothing but 5 into 4 factorial. So 4 factorial is nothing but 4 into 3 factorial. 3 factorial is 3 into 2 factorial, which will go on till the value goes to 1. 1 factorial is 1. 5 factorial ultimately will be a multiplication of 5 into 4 into 3 into 2 into 1. If you look at it carefully, you will see that it is a loop or a sequence in a decrementing order. So if I want to basically devise an algorithm for this one, I can basically do it using loop, wherein I can decrement the values by exactly 1 and find out the multiplication of this one, or I can do it using recursion, wherein if you see right from the first step to the last step, it is basically nothing but calling the factorial function itself, but with the decrementing value by exactly 1. So let's illustrate this further by programming this particular algorithm in Java itself. So I can go to my IntelliJ workspace. I'll create another class called as Factorial using recursion. Factorial using recursion, and let me go to a presentation mode. Okay. Now what we'll do is we'll get the user input for which he wants to calculate the factorial. To get an user input, Java provides us with the beautiful little utility called as scanner, by which we can read the user input from the console itself. So I'll first declare one main method, and we'll get user input as a scanner, which is the utility that we're going to use. And this utility will need a standard user input as an constructor argument. Okay. Now let's give a message to the user saying that he needs to enter a number for which he wants to calculate the factorial. Now let's read this number into an integer variable. I say int number is equal to scanner dot next int as a next int, or because next will give you the string value. We need an integer, so we'll say next int. What we'll do now is I'll just print out the factorial of a number, let's say n, or number is, and what we'll do is we'll create another function called as factorial, and that will have a user input which is number. Okay, now this is turning red. We need to create a function called as factorial. So let me create a private function in the same class. I say factorial. It will need a integer as an input. Okay, now what we need to do is basically factorial of number is nothing but multiplication of the number itself and the factorial of value 1 less than itself. So what we mean by that is number itself, and because it's a recursion, it will call the same function itself. Okay, number minus 1, and this exactly is the same value we need to return back. Okay, now what is the breaking condition for this particular recursion? The breaking condition is if the value of number is 1, okay, then its factorial is 1 itself. Okay, so that will be your breaking condition. Now this has to be static because you're calling it from a main method itself. So let's run this and let's find it out whether we do get the correct response back or not. So let me try to find it out, the factorial of, let's say, 5. So factorial of 5 is 5 into 4 factorial, which is 4 into 3 factorial, which is 5 into 4 into 3 into 2 into 1. So its value is basically 120. Okay, so we are getting the value back correctly as 120. So our program is working fine. If I want to run it for, let's say, another value, I want to calculate the factorial of 3, which is 3 into 2 into 1, which is 6. Okay, so programming is working perfectly fine. So if you have reached till now, user may ask you a question, as in, now your programming knowledge has been tested. Now they will test your algorithmic knowledge. Okay, so they will ask you what is the time and the space complexity of this particular program. So to answer that question, you need to understand what exactly is the complexity. So in computer algorithms, complexity is defined in two terms, time and the space complexity. Time is nothing but how much time this is going to take to run the complete program, and whether it is increasing linearly or exponentially. Okay, the space complexity is nothing but what is the memory consumption of your algorithm, and again whether it is increasing sequentially or linearly. Okay, so if I take an example of this particular program itself, or this particular algorithm, what we can observe here is basically if I say to calculate the factorial of, let's say 5, what I need to do is I need to run this particular factorial program. If you see here, this will get run for exactly 5 times. If I do a debugging and find it out how many times this is running, this will run exactly 5 times. If it is factorial of 3, this particular loop will get called for 3 times. First for 3 factorial, so then when it comes inside here, it will call 3 into factorial of 3 minus 1 is 2. Again this will be called, so it will be 3, it will be 2, 2, and then factorial of 2 minus 1 is 1. So this is a third loop, a second loop. When the third time it will call, it will be value 1, and 1 it will get returned from here itself. Okay, so this will be getting called for exactly 3 times. For 5 factorial, similarly it will get called for 3 times. So value is basically linear to what the user input is. So I would say that my factorial of a number or the complexity is basically linearly increasing. So if for 1 it is taking 1 unit of time, so for n it will take n unit of time. So my complexity for this particular recursion algorithm will be O of n. What will be the space complexity? Space complexity is nothing but how much memory consumption you are taking and whether it is increasing linearly or not. So to answer that question, you need to understand how the recursive function basically works. So the recursive functions basically is a function which is calling itself. So whenever the function calls itself, it is basically putting the same function into the stack again and again. Alright. So number of times your recursive function getting called, those many entries are getting created into the stack itself, and whatever values you need, this is getting copied again and again onto the stack. So if I call 5 times, 5 entries will be there into the stack with the same function. Okay, so again this is increasing linearly with the whatever is the user input. So space complexity will again be O of n, which is more than if you do it with the looping. And if you want to find out how the looping technique is better in terms of calling the factorial of a number, please go through the programming video that I have created to calculate the factorial of a number using loop. The link will be there into the description box. Okay, so both time and the space complexity for this particular algorithm will be O of n itself. Okay, so that's pretty much it from the factorial of a number. And if you want to find it out similar type of questions, or want to find it out, want to prepare for a programming interview, want to understand the Java language features, please do like, share and subscribe, and stay tuned to Java Fun. Thank you so much.